Hi everyone, I'm Valentina Rossi, Corporate Marketing Specialist at Zappi Group. Welcome and thank you for joining us today. Just a quick note, this session is being recorded and will be available on demand afterwards. If you have any questions during the session, please use the Q&A tab on the right side of your screen. Your question will be sent privately. Now, it's my pleasure to introduce today's speaker, Giulio Gaioni from Ubiquicom. We'll talk about a connected ecosystem for safer, smarter electrification. Welcome, Giulio. The floor is yours.
Thank you, Valentina. Thank you for the opportunity that you gave me and Ubiquicom to present at FOE. My name is Giulio Gaioni. I'm the Sales and Marketing Director of Ubiquicom. I have an engineering and consulting background. I've been in technology for the last 30 years, and I've been supporting a large corporation implementing worldwide technology plans, specifically in my experience in Accenture, and I've been now with Ubiquicom for 5 years. So giving you a little bit of a quick presentation of Ubiquicom. Ubiquicom is a company that has been in the market for approximately 20 years. We started as the specialist of RTLS, real-time locating systems. Our objective has been in these years to provide meaningful applications to the industrial and logistic sector, specifically combining process information with data coming from the field. We develop our own technology. We have patents, and we have joined Zappi Group at the end of 2024. Our offering encompasses a set of different systems which are part of our connected ecosystem. This includes telematics, remote diagnostic, safety and collision avoidance, and real-time locating systems. If we are now looking at what is the state of the market, and if we consider that telematics started as an aftermarket product, we actually see that telematics is becoming a part of the standard offering of a vehicle, and is moving into a more mature cycle where, if we look at what's happening into the automotive sector, which is almost a de facto standard, we expect that adoption in the next 5 to 10 years will also reach a full adoption also in the industrial sector. This is actually a great opportunity because telematics is the base and the opportunity to build higher value application and systems on a vehicle and improve significantly safety and efficiency in the way in which the logistics and industrial sector can work. If we try to provide let's say a structured view on the type of value drivers that a connected ecosystems can bring to the market, we organize this into visibility, compliance, automation, and orchestration in terms of, let's say, a pile of growing value that we can bring into the market. When we talk about visibility, we mean the fact that by being able to trace fully movement and data coming from vehicle, from pedestrians, so from employees, and eventually from assets, actually we have a full understanding of what are the process within a specific work environment, and there is a lot of opportunities of improvement that we can do at this level. Compliance, in the same way, combines regulations elements with quality elements. If we consider that we know what a vehicle is doing, when a vehicle is working, where a vehicle is placed, of course, there are a lot of elements in terms of compliance and quality that we can build and we can extract from that information. We can automate a lot of activities of resource utilization, resource reporting. In the same way, considering that we know what are the activities that need to be performed, simply connecting, for instance, with an ERP like a WMS system, and we know where the vehicles are and we know where the employees are, we can definitely orchestrate flows of these different resources and significantly improve efficiency within a production or logistic site. If we see how in this slide we have tried to make a parallel in the way in which the different technologies which are part of our ecosystem, but any standard connected ecosystem, these technologies supports different value drivers that we have identified, of which the final objective is actually to improve in a significant manner safety and efficiency in the work environment. Looking a little bit more in detail, which will be also the subject of this presentation, we will highlight what are the supporting business case behind this technology. Specifically, telematics support a business case for the OEM, as it gives transparency on the way in which vehicles are used. It provides a business case to the leadership, a business case to fleet managers, a business case to rental companies, as it provides means to understand, of course, how these resources are used, provide remote diagnostics, improve service as well. And it provides a business case to the end user. End user also in large organization not always have a clear visibility on how the fleet is used, and having this type of information allows significant improvement in the resource usage and, of course, cost of executing work on the production and logistic floor. At the same time, collision avoidance is typically a sector where we believe that the main driver is compliance. Compliance is, of course, law enforcement and risk management is, of course, an important driver in the adoption of collision avoidance systems. But the reality is also that a non-safe environment is often more expensive than a safe one. If we just consider cases of mortal accident, these often impose the lock or the closure of a site for multiple days. And of course, the cost associated to these events is huge compared to the cost of adopting collision avoidance solution. RTLS is typically supported by a better usage of resources. In the case of resources for RTLS, is not only vehicle, but also it is assets and production or tools which are used during the production execution. So in the remaining of the presentation, I'll spend some time driving through a number of real-world examples where we have implemented these technologies, both at the end user side as well as the OEM level, typically always for large and international corporations or for some relevant Italian companies. So we are covering now the fleet management use cases. Specifically, we have implemented fleet telematics systems among the different systems that we have implemented in this last 20 years for Mitsubishi, for the European branch of Mitsubishi, which is composed of operations in 9 different EMEA countries, as well as for a large transport organization, one of the largest European, but also worldwide leader in transportation, for a specific use case of temperature control. Of course, always the key drivers of a telematic implementation is the opportunity and the possibility to provide real-time visibility of vehicles, being able to trace these assets in the field, and mainly improve resource usage, resource allocation, as well as in some situation implementing flexible contracts. When we mean flexible contracts, we mean the possibility, especially in both in long term, but as well as in short term contracts, the possibility to variate the cost of a contract depending on the level of usage of the resources. Of course, a forklift that is used 24/7 generates a different cost in a forklift that you use once per week, and therefore the importance of being able to implement flexible contract is also the importance of being able to enable opportunities, business opportunities, where these opportunities typically will not be accessible. A relevant topic as well in large fleets management is maintenance. UIM business today, but as well as the automotive business today, is very much driven by the service organization. In the industrial sector, there is also legislation around when maintenance has to be performed, how often maintenance to be performed, and therefore having clear visibility on how a vehicle and when a vehicle is used is relevant to determine when maintenance should be scheduled. Today, often in the market, maintenance is more time-based, meaning that is performed every, for instance, 3-4 months at regular intervals, whereas there is a big advantage and a big cost savings if we're able to schedule maintenance and preventive maintenance based on the usage of a specific vehicle, where of course we would avoid to over maintain a vehicle that is not used, and we would avoid breakdown of a vehicle which is under maintained but highly used. At the same time, the possibility to have a remote diagnostic on the vehicle will also give us the possibility to intervene in case of serious alerts being raised on the vehicle. Compliance is also a relevant topic. The world in which we move today is based on a lot of operational standards, and this type of technology allow enforcement of the relative legislation and standards being required by operating business. Specifically, as I said, required maintenance. We're also covering the case here of temperature control. The business of temperature control enforces the fact that there's to be specific temperature thresholds, and through telematics, we can monitor this type of information. So if we look at the solution that we have implemented for material handling, we have a telematics unit installed on each vehicle. This telematics unit is connected to the canvas of the vehicle, has access to canvas information coming from all the components of the vehicle, being motors, especially for an electrified vehicle, which is the scope of this FOE, as well as the business of our company. Therefore, as motors, inverters, battery chargers, electronic control unit, the DC converters, batteries, a whole set of connected devices which provide information. This information can be collected, filtered, analyzed. and provides users, which are OEM dealers and end users, to access to a portal to this rich set of information and perform high value activities such as predictive maintenance, very relevant on monitoring battery health, an expensive component in an electrified vehicle, remote diagnostics, understanding what's going on a vehicle, avoiding on-site visit and expensive support service operations, provide to the OEM the opportunity to perform over-the-air software updates. This is very relevant in the initial phase of a launch of a vehicle, where there are still some maturity errors that need to be corrected, or there are situations in which there are relevant safety issues, and therefore we need to act, very rapidly on the vehicle, and the standard maintenance is not sufficient. So this is, a very key functionalities that can be enabled, but as well simple intervention on the vehicle, which not require on-site visit, but can be performed with remote configuration. At the same time, there's always a safety component on a vehicle, which includes, the possibility to have access control, so verifying who is accessing the vehicle, making sure he has all the authorization to access the vehicle, having a log history, knowing who has been performing a maintenance on the vehicle, who has been driving the vehicle, and as well as pre-operational checklists, making sure that the vehicle is in a good state before being used. As I mentioned, these solutions are enabled through a rich portal, and through the portal we can collect data, perform reporting, log alarms and notification, being alerted. We can manage all the administration tasks, such as fixed contract, eventually some operational tasks with dealers. Of course, understanding the locations of the fleet, as well as I said, well, we have access control, log all the operators, their badge, and managing the status of their patents and driving permits. As we're moving in a different way, in which we can enable the value of telematics, and specifically, as I mentioned, in the transport sector, in this case, we have improved significantly the cost of temperature tracking solution, as well as tracking, fleets on the field. Whereas in previous situations, without a telematics component, every temperature sensor needed, they were called data logger, and they needed to have their own connectivity to provide real-time information to the base, or this information was happening, let's say, at the end of each trip, on a daily basis, or on a weekly basis, providing delayed information. Whereas today, with a simple sensor which connects to the telematics unit, we have full traceability of temperature in real time, from the cold room up to the door step, when, for instance, goods are delivered, since the sensor keeps tracking information and download that information to the telematics units when it is in reach of the telematics unit, or let's say the cell control in the cold room. Again, there's always a software component which provides detailed visibility of every sensors, being that in the cold room, being that on the vehicle, or being that in the field while the goods are delivered. If we move into the safety and industrial use case, this is also a use case which gains value being implemented on top of telematics solutions, We have selected a few use cases in the industrial sector, typically in recycling, plastic recycling, in paper mill, and as well in a situation where we have an interaction between man and vehicle and automation, which is in the agriculture sector, through follow me type of solutions. So if you look at the specific needs of the customers, the requirement was to be able to reduce risk on recycling waste management sites, where there was a large variety of vehicle within the site, and interaction between vehicles and pedestrian. At the same time, it was also important to be able to trace and to track the movement both of vehicle as well as pedestrian, because it was important to create advanced rules and, for instance, making sure that some specific areas would be clear of pedestrians while they were critical operations. Example was loading and unloading gases, which, of course, need to make sure that there are no operators close to where these operations are taken care. Another relevant element, which is always often or always present in a type of safety monitoring type of situation, is the fact that collision avoidance systems improve safety prevention, but at the same time, HSC are not on site 24 by 7 and cannot continuously monitor the behavior of operators in the field. And therefore, it is important to actually monitor and keep track of what's happening on the site, to be able to provide statistics and reports to the HSC, understand what kind of risk are being detected on site, and what kind of preventive measure can be implemented. Therefore, indeed, a full end-to-end solution does not only take into consideration the operational collision avoidance among vehicle and pedestrians, but there's also a number of preventive measures, and as well typically requires to be able to trace information or to collect near misses and to be able to produce risk heat map or risk reports to understand where the danger is, where the risk is, and what kind of preventive measures can be implemented. So if we just look at the typical use cases, as I said, if we go down, one step is of course collision avoidance. It's not only collision avoidance; it's also, for instance, accident detection. Accident detection, means being able to detect an important impact, and on the basis of that impact, for instance, deciding to lock the vehicle and require supervision. We need to be able to manage safety areas. So, for instance, force slow down on specifically clearly identified areas. That could be an area where there is an interference between vehicle and pedestrians. It could be a specific crossroad. But we might be able also to implement advanced rules and as well, for instance, collect man down alarms. In these two, actually three cases, so slow down, man down alarms, as well as data collection, risk assessment, the role of telematics is fundamental, because these type of functionalities cannot be implemented without connectivity. So if you look at the specifics of what it means, collision avoidance, or the typical use case of collision avoidance, they imply, of course, vehicle to vehicle of different types, vehicle to pedestrians, man-machine interaction. So it could be robots, it could be belts, it could be AGV and pedestrian. AGV, they have their safety mechanism. They typically use LiDAR. On the other hand, LiDAR is not able to detect, if it is colliding with another vehicle, or colliding with infrastructure, or colliding with pedestrians. And of course, typically the safety distance are different, and therefore knowing also in interaction with the AGV that I'm interacting with another vehicle, or that I'm interacting with pedestrians, is relevant to improve, effective safety measures. An AGV can pass very close to infrastructure, but maybe not so close to a pedestrian. So if we look at different type of configuration, considering that safety can have different level of requirements depending on the site, it is important that a safety value proposition is modular and can be scaled. So a typical configuration is a local configuration where collision avoidance, or let's say radar systems, are installed locally on vehicle, AGV, and pedestrian. It can be confined, meaning that we can add infrastructure to improve safety at specific areas, as I said, a crossroad, or an area where, for instance, vehicle and pedestrian are collaborating. But at the same time, a more high value type of situation needs also to understand the exact position of pedestrian and exact position of vehicle within an industrial or logistic site, to implement what I before mentioned as advanced rules. For instance, we need to slow down vehicles in the morning while they are loading and unloading bays from 8 till 12 o'clock. We need to make sure that when we have a congested situation, or too many pedestrians or too many vehicles, we force a slowdown of the vehicle. This type of situation can only be done when we know the exact position, and not just the relative position among vehicle and pedestrians, and therefore connectivity and real-time locating systems is required on top of a local safety system. Yet again, in this type of situation, there will always be a local solution as well as a connected platform. And through the connected platform, for instance, in this case, we would be able to identify areas of the site, design fences, nested fences, a specific rule applied on those fences, trace information on the movement of the vehicle, the interaction among vehicle and pedestrians, generate a heat map, and eventually, notify events, as for instance, an impact of a vehicle, an accident of a vehicle, so that we alert the supervisor on the site, so that he can have a clear visibility of what's going on, the type of impact on infrastructure, making sure that an infrastructure does not collapse due to multiple hits on the infrastructure, and therefore have a more transparent and a better view of the risk on the site. Collision avoidance applies to multiple sectors and to a wide variety of vehicles, and therefore, yet again, being able to provide a modular and flexible collision avoidance safety systems is fundamental to be able to address this market. We're moving now to a use case of optimization of ground support operations. We have different situations which we typically address. This can be the ground services operations within the airport, as well as the facility management within the airport. We will address now a use case that we have implemented for, yet again, a large international transport operator, specifically in the cargo sector, where actually there were significant challenges in locating dollies, container dollies within the Malpensa airport, within the airport, which is of course a very large area. Dollies are not intelligent, therefore it's very difficult to determine where they are and where there are empty dollies that can be used during the operations. And therefore, of course, the challenge that the customer was facing was, overstocking dollies for its own operations. And at the same time, it was always difficult sometimes to locate where the containers being transported by lorries were located. And therefore, sometimes it was challenging to close the loading list before, letting a plane to take off. The airport also has very strict regulations on where a vehicle can move, the speed of the vehicle, being able that are unauthorized, being able to trace the fact that they are unauthorized and they are not in unauthorized areas. And as well, especially dollies, they're not the intelligent component, and therefore it's very difficult to be able to determine what is the distance that these dollies have performed, and therefore, yet again, very difficult to perform, meaningful maintenance, which is typically done on a timely basis rather than on a usage based, generating significant cost inefficiencies. So the situation was, as you can see, managing a fleet of very variated type of vehicle, from dolly, belt loader, operational vehicle moving on the airport, tractors. And the use case that we had to implement for the maintenance team was being able to, as I said, trace the dollies or the vehicle utilizations and the number of kilometers performed. Needed to, being able to determine maintenance, and as well when maintenance was required, being able to find where the specific dolly, was located. At the same time, the tractor drivers, when they were running out of dollies, they needed to identify where empty dollies were available. The control tower, on the other hand, managing the traffic and managing the loading of the aircraft, needed to make sure that the loading list was completed so that the plane could take off. Often a container was missed. A container was placed in the wrong bay, and therefore was problematic to find that missed container. And all of these had to happen, under the supervision of the airport authority that needed to make sure, that vehicle, were not exceeding speed limits and were not going into, unauthorized areas of the airport. So the solution that we implemented has been a mix of, telematics, safety, and tracking services. Typically, installing a telematics component on tractor and on operational vehicle, as well as active tags on the dollies. All this information was collected and flowing to a cloud platform, providing access to the relevant people in the previous slide, meaning the maintenance team, airport authority, logistics control tower, as well as operator running on the field. It's a small example of the platform as well. You can see that the airport we could locate all the different elements. We can type them, so we can make sure that different objects have a different color, distinguishing dollies from tractor from vehicle. So for the position, you might see that there are some specific fences being defined, so rules can be applied on those fences, as well as the possibility to trace the movement, calculate the movement of each specific dolly, so that we could maintain the number of kilometers performed by each dolly and determine the right sequence and maintenance moment for each dolly. Moving to the next use cases, this is an application or a part of our offering, which is a position-based optimization that we perform typically in warehouses or in production environment. These are two large or relevant Italians 3PLs and then 4PLs, whose business is, of course, outsourcing operations for large corporate companies, and their main driver is maintaining, of course, we're talking high intensity warehouses, so high traffic speed in the warehouse. So safety is, of course, an important concern, and safety, of course, does not have to be at the cost of productivity, and therefore also improving productivity and specifically service is a relevant goal of these players. So yet again, one of the objectives of the solution that we have implemented was the reducing the time and the distance that operators would spend traveling without a load in the warehouse, resolving congestions and bottlenecks that happen, of course, when there's a high traffic within a site, as well as being able to manage in a effective way volume peaks and unexpected events, which are situations which are difficult to manage without avoiding overhead. All of this with the goal of guaranteeing service level and often service levels with the ability to perform tasks when required. For instance, finishing the load of a truck is and guaranteeing a certain service level is often more important than the cost of the overall operations. So the solution that we have implemented is called for us Synchro. Synchro gives us the possibility to model the warehouse within a software platform. Therefore, knowing the positions, the stock positions within the warehouse, and knowing where the layout of the warehouse, where the alleys, where the traffic will be managed within the warehouse, and interfacing our platform with WMS, we will be able to collect all the task waves that would need to be executed on the operational logistic floor and optimize them by having not only an understanding of the warehouse, having a map and a model of the warehouse, but also knowing in real time the position of the operators. Therefore, the objective of our algorithm is actually the one to perform forecasting in the future and creating a list of ordered tasks and making sure that each operator would perform an optimized sequence of tasks. Therefore, the objective of this system is not only to guide, or to navigate operator within a warehouse. A warehouse is actually a fairly simple structure, so we don't need to give instruction on how to move to an operator, but we need to create the right sequence of tasks to make sure that he would perform them in sequence so that it would optimize his movement within the warehouse. And this, of course, generates savings in terms of time that is spent to execute tasks, as well time that is spent without a load. So, just to give maybe a clear example of this. What does this mean? In typically in normal operations in a normal warehouse, an operator is assigned to the loading and unloading of a truck. And when he's either loading or loading a truck, he typically pick up a pallet from the bay, and he brings a stock, and then he goes. So then it will be loaded, and then he goes back unloaded. The same it would perform if you would actually load a truck. Therefore, it would pick from stock and it would bring to the bay, and then it would go back unloaded. Therefore, productivity would probably be around 50%. What actually Synchro does is actually mixing loading, unloading, transferring all kind of different tasks, making sure that actually the operator is moving from one task to the other. Maybe here I can give a bit more of an example of the dashboard, where actually if you see into is not very clear, but if you see here, you would see the list in light blue. You would see the list of tasks that the operator would have to perform, and the system actually puts them in sequence so that the distance that the operator performs is optimized, and the distance it performs without load is actually minimized. This solution actually works on top of a fleet management systems, and therefore can be implemented to optimize the scheduling of a manual warehouse, but it can also work at a higher layer, mixing a fleet of manual vehicle together with a fleet of automated guided vehicle. The dashboard actually, it provides a digital twin of the warehouse, so it's actually possible to see in real time the position of the vehicle, what each vehicle has been executing, productivity of each vehicle, idle time, level of usage of resources, and therefore providing a tool which gives very high visibility of what's going on in a warehouse, and an opportunity to optimize the usage of resources. I am done with the body of my presentation. Well, I want to thank everybody. I know it's been a lot of information, so apologies for driving through so fast. So I wanted to give you now the opportunity to share some questions, if there are any.
So thank you, Giulio. And yes, we have some questions actually. So the first one is regarding the Malpensa case. They want to know what are the metrics that have been used for the business case of the Malpensa airport.
Yes, indeed. There were actually, as I presented, there were multiple use cases that have been implemented for Malpensa. Initially, it started as being able to optimize maintenance for the dollies, managing the dollies, as I said, which were not intelligent components, so there was no information on those dollies, and therefore the first objective is actually being able to trace the distance that these dollies were performing, and the business case and actually objective has been to reduce maintenance of 10%. Well, even if 10% doesn't seem to be a high number, given the number of dollies, which were probably $300, and consider these are expensive dollies, and maintenance has a cost of several hundreds of euros. Actually, the initial business case was based on this. Then in a second phase, also was relevant to understand where those dollies were located, and then in that case, the driver was reducing search time for the operators. The airport is is very large, so it's not something that you can, you do not see where a dolly is by just looking around. So you need assistance for that. And the driver has been a saving of 15 minutes of search time per operator, and as well the ability of being able to use these dollars in a more effective time also made it possible not to, let's say, over purchase dollars. And the matrix it was achieved was a 5% improve in usage, which also meant a 5%, reduction in the number of dollars being used by the operations.
Okay. And the Ubiquicon collision avoidance system works together with other collision system or that are basically already installed in the fleet or not?
It depends actually on the type of technology that you use. Well, the market today is split among radio frequency based technologies and camera based technologies. Typically, radio frequency is a more mature system, but it is more difficult to make it work in a heterogeneous environment, meaning intercompatible with other available collision avoidance system, because often it uses proprietary technologies. On the other hand, camera-based systems are maybe less mature, so they still raise a higher number of false alarms today. So it has to be evaluated depending on the context. But on the other hand, it can be intercompatible, meaning that you can have different systems installed on different type of machines.
Okay. So a couple of questions more. During the session, you introduce your strategic approach based on a connected ecosystem and outlined the main value driver. Could you elaborate a little bit more the benefits in terms of visibility?
Yes, when we say visibility, in reality, it is process visibility, and so it's the ability to understand better a process. So it's being able to trace that process, and from the ability to trace that process, it means also collecting some elements of intelligence and some elements of value. Therefore, end-to-end traceability, of course, provide us usage. So as we know how much we're using a resource, we can optimize that usage. That there are often, procurement executives are always interested in the usage rate of a fleet, because they can optimize, the cost of that fleet, for instance. Maintenance, as I mentioned, is based on usage. So if I'm using a resource more, I will have to maintain that more. So having visibility of that information, it provides intelligence as well. So possibility to implement a more efficient maintenance strategy or operations. Also tracing, meaning it also means having that information, for instance, in real time, right? So being able to provide dashboards, being able to collect alerts. So having an alerts because at the Malpensa airport a vehicle is on the ramp while an aircraft is taking off. Well, it's very relevant. So there is value in that type of use case. And as well, collecting information, being able to make data-driven decisions. That's also relevant. Being able to trace the number of near misses happening on a site gives us visibility on the risk level of that site and the risk level of that location in that site, and therefore what type of preventive measures we can put in place to address that. So, there is benefits at multiple levels.
Okay. And last one, what technology do you see winning the market in the collision avoidance space?
Yeah, so as I mentioned before, collision avoidance is becoming a technology which is getting more and more relevance. Maybe it's not yet as relevant as telematics, but it's, as I said, there's a take up. We're seeing a take up in the market. There is an history behind collision avoidance. It started with RFID type of technology, which were not very efficient. We don't see many solutions based on RFID today. LiDAR sometimes is also being used on collision avoidance. Today, LiDAR is seen a little bit as expensive on one end and not being able to, for instance, as I said, differentiate objects, vehicle, pedestrians, and therefore apply different collision avoidance strategies. The two today forerunners in the market, as I mentioned before, are radio frequency and camera-based type of technologies. The most efficient that we see is radio frequency. Of course, radio frequency eventually is very relevant on specific use cases, on specific contexts, less on others. When it's less, is because it requires, we just said before, to be installed on any vehicle, and also requires the adoption of a tag for the operators that are moving in the warehouse. Very precise, but okay, sometimes this can be a hurdle. On the other hand, camera-based approach is easier in terms of adoption. It is intercompatible eventually, and it does not require the usage of a tag because it can recognize pedestrians without with image recognition without the use of a tag. On the other hand, it is dependent on environmental conditions. It is not yet as mature as radio frequency technology. Therefore, is relevant on is more relevant. Is improving the safety conditions. Therefore, it has a meaning in the industrial context, but is relevant, for instance, more relevant into the construction industry, as an example.
Okay, thank you, Giulio. We don't have more questions at the moment, but feel free to use the Q&A box. We will reply basically in a second time. And thank you for attending this session. Please join the next session from the lobby. Thank you all.